Hello, everyone. Thank you for joining us today. I think you can all hear us now. So you're here for the conference on vertical flight agricultural operations. My name is Tuva. For those of you who don't know me, I am the president of the Montreal-Ottawa Chapter of the Vertical Flight Society. I'm also a senior manager here at Bell Flight for new development products. I'll be the moderator for today's event. Chris, if you can just maybe share the slides. Perfect. And can we go to the first slide? Okay. All right. So here's just a quick summary of the executive team here at the VFS chapter for Montreal-Ottawa. We've got representation from 4 different aerospace companies on the board. We also have 2 university chapters, both Concordia and McGill. And I'd like to take a moment to congratulate the McGill student chapter on receiving an honorable mention for the best drawing package in the inaugural Design Build Vertical Flight student competition. If you do want more information on the Vertical Flight Society, please do reach out to any of us. On that note, Chris, if you can go to the next slide. I just wanted to take a minute to talk about the Vertical Flight Society itself and our mission. The VFS was founded in 1943 as the American Helicopter Society. It's the world's only international technical society for engineers, scientists, and others working to advance vertical flight technology. Our mandate is really threefold. One is to increase interest in vertical flight across Canada. 2, to create a platform to facilitate networking and collaboration. And 3, to provide learning opportunities through exclusive conferences like the one you're in today. We're always looking for new members and active participants. So if you are interested in helping to advance vertical flight, please reach out to us and join us. And just the next slide as well, Chris. So now for the part that we're all here for, our speaker series on vertical flight agricultural operations. I'm very excited to be introducing our lineup of speakers here today. First, we have Ken Swartz, a member of the VFS board, a senior editor for Vertiflight magazine and Electric VTOL News. Ken has 30+ years of experience in the aviation industry, and he'll be giving us a historical perspective of agricultural operations. Next, we have Wesley Reid, the vice president of our chapter in Montreal-Ottawa and the lead product manager at Dart Aerospace. He'll be briefing the design aspects of aerial spray systems. Wesley has over 14 years of experience in aerospace, touching on fixed-wing aircraft maintenance, helicopter structure design, and technical marketing of helicopter mission equipment. Next, we have Mozhdeh Shahbazi, who's the applied science manager for the Centre de géomatique du Québec. We'll be discussing the latest research in agricultural operations. Mozhdeh does hold a PhD in applied geomatics and remote sensing, and is a professor at both the University of Calgary and York University. And finally, we have 2 speakers from DesChamps who will be discussing agricultural spraying operations using UAVs. Nicolas DesChamps is the founder of DesChamps. He comes from a family of farmers and is an experienced drone pilot and passionate about innovation. And then we have Weisman, who's the technical director of DesChamps. He holds a master's degree in business and has extensive experience in distribution, negotiation, and entrepreneurship, having founded an e-commerce company in Canada. Now I'll stop talking and I'll hand it over to Ken, who will get us started.
Okay, hang on one second. I'm going to start my timer. Everyone hear me okay? Okay, next slide, please. Next slide. Next slide. Okay, so today's session, we're talking about agricultural applications of vertical flight. Just want to give a Canadian context to this. Canada is the 2nd largest aviation market in the world when it comes to aircraft. We have over 36,000 aircraft. We're also the 2nd largest helicopter market in the world with over 2,800 helicopters. We're also the 2nd largest country in the world. So one of the characteristics we have is that there's a lot of aircraft spread over a lot of territory, and a lot of what takes place is really out of the public view. And in many respects, that applies to the aerial application industry. With the exception, let's say, of gypsy moth infestations in urban areas, we generally don't see agricultural aircraft anywhere near where most of the population lives. If we look at what the market is today, there's approximately 500 agricultural aircraft in Canada. 90% of them, in fact, are fixed wing, and the industry also includes the commercial operators that fly these aircraft, the aircraft manufacturers in Canada that sell these aircraft, primarily Bell as a helicopter manufacturer selling aircraft around the world. And there's a number of leading technology companies in Canada that also make equipment for this sector. AgNav is one of the largest distributors of aerial navigation systems for agricultural aircraft. DART, as a conglomerate, has a number of product lines associated with this market. And then we have some of the operators like Forest Protection who developed and innovated systems for their own aircraft fleet and for others as well. Next slide. So from a historical perspective, a lot of the early aviators in Canada came out of the First World War. They were on the Western Front. They used aircraft for aerial observation. And when they came back to Canada in 1918, 1919, they started to put their expertise to work in the field. So the first forestry use of or aerial dusting operations occurred in the 1920s. It's important to point out that aviation in Canada developed along a different trajectory than that of the US or Europe. In the 1930s, the majority of the working aircraft in Canada were on floats and skis, not wheels. They were working in the northern areas. Canada led the world in terms of air cargo in the 1930s. There was a focus much more on aviation as a tool than a means of transportation between cities and airports. The first agricultural use of a vertical flight aircraft was an autogyro in the 1930s. Next slide. So this is the Fairchild Pitcairn. This aircraft was assembled in Longueuil and did some demonstrations across Canada. Next slide. Levins Brothers bought a Pitcairn in 1932, and this aircraft was used into the early 1950s for aerial applications, rides, etc. It was the only rotorcraft in Canada at the time doing agricultural work. Next slide. Helicopter history in Canada begins really in 1946 with the certification of the first Bell 47. The Bell factory was in Niagara Falls, New York, so it was literally 5 miles from the Canadian border. And so they came across Canada with the early Bell 47s, and a lot of the early marketing was focused on aerial applications. In fact, the first 7 Bell 47s bought for Canada were for ag kits. Only one of those aircraft survived the first operating season because of accidents. And the operators very quickly found out that agriculture was unprofitable when you were competing against surplus aircraft in the Second World War, and they needed to find higher value customers. So our industry pivots into bush flying, working in the north with helicopters where there were no other means of transportation. Next slide. Next slide. So Bell sponsored a program in Argentina with fighting locusts. They gave a lot of publicity. That inspired a lot of sales. Next slide. This is down in Leamington, Ontario. This is the first helicopter in Canada, dusting, I think, tomato orchards. Next slide. Okanagan Helicopters, or Okanagan Air Services, was actually funded by orchard owners in the Okanagan, and this is the first helicopter in British Columbia. Okanagan became CHC, one of the largest helicopter companies in the world, through a series of mergers. Next slide. Here they are doing dusting in the Okanagan, and later that summer they hit a power line. Next slide. Cammon Helicopters in Connecticut came to Canada in 1948 with aircraft, and they demonstrated for agricultural use. Next slide. Sikorsky came to New Brunswick in the early 1950s with an S-51 and demonstrated it to Forest Protection, which was fighting budworm. Forest Protection contracted up to 150 spray aircraft in the 1950s. They never contracted a helicopter except for search and rescue. Next slide. Hillers were also used. They did aerial fogging. I'm not exactly sure what that is. It's not spraying and it's not dry chemicals. Next slide. Ontario Hydro was the first corporate helicopter operator in Canada. They bought the first turbine for aerial application in 1959. It was basically a payload issue. They could replace 2 Bell 47s. Next slide. Through the 1960s, there's a lot of innovation in terms of spray systems. Both these show systems that are suspended from helicopters, a Bell 47 on the left and a Hiller FH1100 on the right. Next slide. Okanagan was the largest company in Canada. They used helicopters primarily for forestry work. Next slide. Some unusual modified helicopters came into Canada, such as the Wasp. It was a modified Bell 47 components, but everything else was payload. Next slide. Joe Soloy in Washington State modified the Hiller, replacing the piston engine with a turbine to increase the payload, called the Soloy Hiller. A number of them came into Canada, and most of the Hillers in Canada today are Soloy Hillers. Again, the objective was increased payload. Next slide. This is the engine installation of the Allison in the, or Rolls-Royce engine in the Hiller. Again, it saved a lot of weight and provided a lot greater reliability. Next slide. Canadian helicopters used spray systems primarily on a seasonal basis and primarily in forestry. So this was really an aircraft that had many different roles during the year. Next slide. And here's an application of spraying or doing work on a cut block. So basically, trees have been logged and it's part of the regrowth process. Next slide. So if we look at the fleet in Canada today, there are approximately 431 agricultural aircraft. And this was basically taking all the fixed wing aircraft types that are dedicated to agricultural use, looking at the companies that are dedicated to helicopter use, and then adding a certain factor for partial aircraft throughout the year. Next slide. Demand is largely commodity driven. Certain agricultural crops, and it's really sort of a function of where they are. And then the types of work that the aircraft does in terms of what it's dropping, herbicides, fungicides, fertilizers, pesticides, larvicides, which are biological agents. And then helicopters are also used as big fans in certain industries for fruit trees, for example, to either circulate air for frost or to remove water so they don't split. It's always a challenging operation in terms of you're working with high gross weights when you're taking off, high density altitudes, unmarked obstacles, and certainly protected areas that you should not spray. It's also a skill set that is hard to learn, and there's not a large group of people. And finally, it's an industry that's open to new technologies such as GPS guidance systems. Next slide. Okay, so this is a quick run through of the industry as it was in the last 10 years. Next slide. So that's a company that uses both fixed wing and helicopters for apple orchards. Next slide. Oh. So I'm running out of time. Larvicide, next slide. This picture basically shows the idea of the helicopter paired with the truck. The truck contains both a refueling and a loading system for chemicals, and it lands on the roof of the truck. And this is for increased productivity. Next slide. Spray systems, how the pumps are driven is a consideration. Next slide. This is fungicides for soybeans and corn in Ontario. Next slide. similar pairing with a loading system. Next slide. Bi-Air has about half a dozen hillers. They do conifer cone release. So they're largely working in forest areas, trying to deter the deciduous vegetation so the coniferous trees can thrive. And they do cone release. So this is also to try and get the trees themselves to drop the seeds. Next slide. Western Aerial Applicators is the largest helicopter aerial application company in Canada, based in Chilliwack, BC. They do primarily forestry, and then they have 4 aircraft on contract to do mosquito spraying in the Winnipeg area each summer. And it's worth mentioning that in Winnipeg, the first application of helicopters in spraying was during the Red River floods. Similarly, in BC, the first aerial application in BC was during Fraser River floods. So when you've had these large floods with a lot of standing water, that was an early application of helicopters, and it does occur today. Next slide. A lot of Western aerial applications work, though, however, is fertilizer for forestry. And this is a llama, which is known for high payload, distributing fertilizer. Next slide. And another shot here where you can see the actual fertilizer load. So this is high cycle operations. That ends my Canadian section, but I'll just show you a couple pictures taken by a friend in Switzerland, just to show you the airflow from a helicopter that's doing aerial application. Next slide. Next slide. So this is a llama air-to-air in Switzerland. You can see the spray configuration. Next slide. Next slide. Okay, this one here shows you the effect of the rotor downwash on the spray and the distribution. Next slide. And this is one of the characteristics of spraying, is that you're doing tight turns at the end of a row and up and then following on the next row. That ends my presentation. We'll take questions later. Please put your questions in the chat. Thanks very much.
Thank you, Ken. We'll transition over to Wesley.
Thanks, Ken. That was very interesting. It was nice to see the history of where this industry started, and so it gives us a better understanding of where we are today. So Chris, we'll go to the first slide, talking about. Well, we'll start off talking about my employer, DART Aerospace. And first off, I'll apologize. The original billing was for my colleague Dan Wright to be presenting this, and so if anyone was expecting the wizened voice of a seasoned veteran, I'm sorry he had to step back from the presentation today and ask me to take his place. But hopefully I can do this material justice. So to talk about DART Aerospace, where I work, we're a company that does mission equipment and replacement parts for the helicopter industry. We've got over 1,100 STCs. For those who are unfamiliar with what an STC is it's an approved modification to an airworthy product. So anyone who knows the process involved to get an STC is, that 1,100 number will seem astronomical. We're about 300 employees. We've got 7 locations, 3 in Canada, 1 in Montreal, 1 in Hawkesbury, Ontario, which is halfway between Montreal and Ottawa, and another in Calgary, as well as a shop down in San Diego, California, Portland, Oregon, which is where we make our tanks and our agricultural spraying systems, and maintenance facilities in Broussard, Louisiana, and Amsterdam. Next slide, please. So Simplex Aerospace was the original company based in Portland, Oregon. They've been in business since the 40s, very, very long storied history. And they started out as an agricultural mission equipment company. And now they're we're much more known for firefighting equipment. They were acquired by DART Aerospace a little over almost 2 years ago in 2019. With a lot of tanks out in service. We estimated around 6,000 systems in service, and 2/3 of those are in agricultural applications. Next slide, please. So as Ken mentioned, prior to the 60s, most systems for agricultural work were slung systems, so they didn't have to be certified. The first STC for an agricultural spray system was issued in 1960 for a Bell 47. And as recently as 3 years ago, we were selling spare parts for this system. So there's some of them that are still out there flying, although I'm sure a lot have been replaced with more modern aircraft, more modern applications. But it goes to show that this is a market that will use the equipment for a very, very long time. Next slide, please. So here's a little cross section of the products that we serve. You'll notice in looking at these aircraft that with the exception of that medium Bell medium in the middle, they're usually smaller aircraft. It's a very cost conscious market as far as applying fertilizer or herbicides to fields. So usually you want the smallest, cheapest aircraft you can use to get that product out onto the field. Next slide, please. So these are the 10 different systems that we currently have in production. So you see a good cross section there. Most helicopter OEMs are covered in there. So usually serving the smaller models of aircraft, but still 10 different lines of agricultural spraying systems currently in production. Next slide, please. The key components that go into a spraying system is obviously there's the tank itself, the reservoir that holds your fluid. Also the fill ports, so you can refill that because as Ken showed in his presentation, these aircraft are landing on makeshift platforms to be refilled. So basically, in one fuel cycle, you'll refill your tank several times. So you need to have easy access to be able to refill your whatever your product you're applying is. Next up is the boom. Obvious, that's an important part to be able to get that product out onto the fields and cover the largest swath you can with every pass. After that, there's the parts that are a bit more bespoke, a bit more tailored to the application. So we do not have a one-size-fits-all tank for all helicopters. Every tank is custom built for its application because it has to fit the curvature of the fuselage, it has to fit the different antennas or pieces of equipment that hang off the aircraft, as well as the lining up the structural hard points where it ties into the aircraft structure. So those are all considerations that have to go into a tank. This tank on screen is for a Robinson 66. Other things that you have to design into the tank is access panels for inspection and cleaning and rinsing after a long day's work, and emergency dump doors, because if ever you have an emergency situation while you're spraying, you want to carry as little weight as possible down to your emergency landing. So you want to be able to drop all of your product in one location and then continue to your emergency landing. So that's something that needs to be designed in to the system. And next slide, please. So all the features I just mentioned, they slide into providing benefits to the operator. So having a certified system is something that's synonymous with safety. If you're using something that's non-certified, the regulator hasn't put it through its paces, and so it hasn't reached that high barrier that is the certified airworthy by the regulator. So that comes with a lot of features like those emergency dump doors, frangible hardware to make sure that the aircraft or the tank itself won't be excessively damaged in the event of a hard landing. It's been flight tested. It's been analyzed heavily by engineering teams and by the regulators to show that it is a safe product. Next slide, please. This is what the inside of a typical tank looks like. So we make our tanks out of composites, sometimes carbon fiber, sometimes fiberglass, sometimes a combination of the two. That gets you a lightweight product that has that can take the abuse of farm life. One thing worth mentioning is depending on the product you're applying, corrosion can be a serious risk. So going with that composite construction and then using aerospace grade corrosion resistant hardware inside everywhere you possibly can, it gives a very long lasting system, because particularly insecticides can be very noxious things that will eat up aluminum or low grade steel with repeated exposure. So that's something that goes into the tank design. Also, you can see the barriers, the side to side barriers in there. Those are baffles to prevent the liquid in the tank from moving around too much, because if you have the liquid unrestricted flowing from front to back and left to right, that can cause pretty radical changes in the center of gravity of the aircraft in flight, which makes handling a bit more of a challenge. Also, by designing every tank to match a specific aircraft application, you end up with a nice aerodynamic profile, which means a higher cruising speed, lower resistance, lower fuel burn, all that. And then, as I mentioned, between the dump doors and the access panels, to do inspections of the product when it's in service and to clean it after every day's work is a whole lot easier. Just things to consider in the design. Next slide, please. So this is where I want to spend the most of my time, and that's the aircraft considerations. What makes an aircraft a good platform for spraying? So payload is first and foremost. If the aircraft needs the power to be able to lift the product. Obviously, your maximum takeoff weight of the aircraft minus the empty weight minus all the equipment and fuel. That's your usable payload of how much product you can carry with you. But an aircraft with lots of power and no ground clearance, well, then that's not going to be a good sprayer either. So you need enough ground clearance to be able to install a tank that's going to give you your space to store your liquid, as well as enough margin to account for all the emergency scenarios you need to consider in the product certification, hard landings and all that. You need a certain amount of ground clearance, even with the tank installed. Next is the aircraft's compatibility with existing operations. As Ken's slides showed, these aircraft often are landing on top of essentially trailers to have their liquid refilled. So if the aircraft's too large, it's not going to fit on that big trailer. Another consideration is, depending on your geography, sometimes you fly your spraying aircraft to the field you're working in. Sometimes you truck it there. So if you're in an area where you need to truck in your aircraft, then it obviously needs to be a small enough aircraft that's easy enough to disassemble, that you can load it up onto a flatbed truck and drive it to that farm. And then economics. That's very important. It's a very, very competitive business to be putting fertilizer and insecticides and fungicides on crops. So if the aircraft costs too much to operate, it's not going to compete with the others that are already in the field. If the aircraft costs too much upfront to buy, then it's not going to be competitive in the field. So, and one last one that's a little bit less intuitive, it also ties into economics, and that's a large installed fleet base. If you've checked off all the boxes above, but the aircraft doesn't have a fairly large base, it might not have what it takes to be a good platform for agricultural spraying. The reason for that is agricultural spraying is very rarely the first job a new helicopter does. It's usually the second or the third or the fourth remissionizing. So if the aircraft doesn't have that thriving secondary market with secondhand aircraft going up for sale and spare parts volume to drive down the operating cost, then it's not going to be conducive to the very, very cost competitive market that we have here. So all that to say that even if it checks all the boxes above, an aircraft needs a certain level of maturity before it'll be a really, really strong contender versus the previously established fleets. And I can say that with using the example of Robinson 44s and 66s, they've seen a real uptick in the last 10 years, how much they're being used for agricultural spraying operations and disrupting the previously established models, the Bell Lights, the Bell 47, the AS 350. Those are aircraft that you used to see doing this mission, and they're really being disrupted by the lower cost Robinsons. So that's all the slides I have for today. I'm really looking forward to seeing what my colleagues on screen have to say about where the future is going in agricultural spraying, and I'll pass the baton to Mozhdeh.
Thank you, Wesley. So yeah, thank you, Thuva, also for the introduction. I think my presentation is not much on spraying in particular, but rather on the precision agriculture itself and use of visual and geospatial intelligence in that field. Next slide, please. So I thought it would be nice to start by introducing my center, Centre Géomatique de Québec, CGQ. Next slide, please. So CGQ is a collegial center for technology transfer, which is affiliated with Cégep de Chicoutimi, obviously located in Chicoutimi, city north of Quebec. At the same time, we have the prestigious status of being the Canadian Tech Access Center with 3 major poles of expertise in photogrammetry and computer vision, in hydrography and maritime cartography, as well as satellite remote sensing and Earth observations. To that end, our mission is to facilitate the integration of novel geospatial technologies into daily operations of enterprises and organizations, mainly through applied research and development, but also through technical assistance and personalized training. Next slide, please. So now let's go back to precision agriculture, which is kind of the focus of my talk today. So to me, the way I can define precision farming is that it's a farming management concept, basically, for optimizing and automating farming practices, or for monitoring various aspects of the farm and the agro-environment in general, based on advanced technologies like information technology, artificial intelligence, mobile robots, flying drones, geolocalization of other farming crews, machinery, or other farm objects, and telematics, where I would try to fit the IoT also in there. So now the part in all of this is of interest to us in the field of geomatics is the monitoring portion, which involves observing the environment with various types of sensors, and then geolocalizing and characterizing various objects or events of interest to the farm management. So in terms of sensors, one of our areas of expertise at CGQ is to be able to integrate various types of imaging, ranging, positioning, and navigation sensors together to be able to collect comprehensive data of the agro-environment. If you can go to the next slide, sorry, Chris. Yeah, so later to the data that we collect with the sensors, we can apply different techniques of geospatial data analytics to extract useful information, again, for the purpose of monitoring various aspects of the farm. Next slide, please. So here are a few types of sensors that we only use for this purpose at CGQ, like multispectral and hyperspectral cameras to be able to observe detailed ranges of spectral information that are not usually visible to human eyes, ranging sensors, different types of laser scanners for understanding the 3D environment, and then positioning and orientation sensors that are usually used for geolocalization purposes. Next slide, please. So here are a few examples of integrated sensors, like the system on the left of the screen. It's a combination of 8 cameras, visible thermal, near infrared, and red edge bands, and the right one, which is integrated LiDAR and camera system. Next slide, please. So of course, when there are sensors, we also need platforms to carry them in the environment, and depending on the extent of the environment to cover, it can be like mobile machinery, flying drones, or even manned aircraft or helicopters to be able to cover larger areas. Next slide, please. With respect to the robotics aspect of precision agriculture, we are also active in finding alternate ways of navigation rather than just GPS or GNSS guidance. For example, in the drone system that we saw in the last slide, we use the camera to provide very accurate navigation trajectory, like centimeter level accuracy, instead of a normal GPS. Next slide, please. So in many farming practices, having an overall visual view of the farm is needed, or next slide. Or even better than that is having an overall detailed topography of the farm for understanding or predicting hydrological events like the runoff modeling, or for irrigation management. And when we say detail, we usually mean centimeter level of information. So in this case, the photos that we are showing, we've used our custom-built LiDAR and camera system to be able to 3D map the environment. Next slide, please. And then we can use this combination of visual and 3D information to remove the vegetation virtually from the surface, so that what's left is the pure soil and can provide the very detailed microtopography of the soil to the farmers as well. Next slide, please. So as I keep mentioning, like multispectral cameras, it's because well, more than, in many cases, more than the visible information are needed to observe the certain phenomena on the farm or the agro-environment. And in the past few years, many manufacturers have started building miniature multi-camera systems that allow collecting multispectral images. And those of you who have worked with these cameras, you know that processing the data of these cameras is quite heavy because you have to deal with a large number of images with several cameras at the same time. One of the ways we used to reduce the processing heavy lifting, let's say, is to calibrate these cameras accurately before going to the farm with respect to one another, and then use the information to overlay the images on each other and removing the need to process all the bands. Instead, you would process only one band and then reflect the results to the others. Next slide. So here we show that two images taken from two cameras in a system don't systematically overlay because the cameras are shifted with respect to one another, and a single 2D shift won't fix the problem either. Next slide, please. So in most practices, we would use a projective transformation to overlay the images unless we have depth variations in the scene, like we can see on the left image with the difference of the ground and the trees. And then for those cases, we've developed an open access software, which is actually now being used by Micasons, the manufacturer of the camera itself, to solve this problem. Next slide, please. So once we successfully overlay these multispectral images, we can use them as multi-layer inputs to classifier and object detectors based on machine or deep learning approaches. Like in this case, we have used the images to detect diseased potato leaves from the images taken by that 8-camera system that I showed earlier. Next slide. So images can be used to predict the yield by counting plants at their early growth stages, like we can see here. Next slide. So in this project, we had developed a density regression deep neural network that predicts the position of the plants as heat maps. Next slide. And then the heat maps can be reduced to count maps, so it allows to count the plants even though they are very small. Next slide, please. So in many applications, it is also useful to segment out the plants from the weeds and the soil and other objects on the farm. So in this project, we have used the semantic segmentation approach, again, based on convolutional neural networks to do this. So the benefit of this process is that plant level or leaf level attributes can be extracted. Next slide, please. For example, here we can see we have extracted the plant level temperatures in a portion of the leek farm where it sounded that plants are going under kind of water stress in this part of the farm. Next slide, please. So as you can notice, there is a nice correlation between the leveling of the field and the temperature of the plants, which is a sign of their health. Plants are just like us, so when they are not healthy, the temperature goes up relative to healthy plants. And it sounds like close to the point A, we have some kind of bumps in the field that doesn't allow the plants to receive enough water. And then down there, close to point B, we have creek-like patterns in the topography of the field, which helps directing the water towards those plants. And that's why those plants are healthier. Next slide, please. We have also conducted chlorophyll content mapping in the same farm, and if we compare the site which suffers from water stress, we can equally see that the plants have also less chlorophyll concentration compared to the site on the left image, which is much healthier. Next slide, please. We've also used AI-based predictive tools to predict the harvesting capacity of different regions for white blueberries based on time series of data from past years. Next slide, please. So we've used similar approaches for other agriculture environments like aquaculture for classifying microalgae that have commercial values using hyperspectral imaging as well on board the aircraft. Next slide. And similar approaches, we've used them for monitoring animals that can be extended to, let's say, a large cattle ranch monitoring. Next slide, please. So that's pretty much the end of my presentation. I would like to acknowledge and thank all these agencies that have sponsored our research projects, specifically the ones that I presented today. So thank you again for your attention, and my email address is here. So if you have any questions, don't hesitate to write to me. Thank you.
Thank you, Mozhdeh. Very much appreciated. We can go on to DesChamps.
Hi. So we are DesChamps. My name is Gilles, and we are a company whose mission is to bring technology to the farming industry. DesChamps was born 4 years ago by Nicolas DesChamps, same name, same company. He's a son and a farmer of a son and brother of farmers back in France. So he has the knowledge, and he knows how to speak to farmer. And he has always been interested in technology, and drone was a good starting point. The company is also managed by Sophie, which is not here today. She's in charge of everything administrative, and I am in charge of everything related to technology and software development. So next slide. So our main business as a drone company, we have 3 sectors. We have agriculture, environment, we have construction, and we have R&D center, just like the CGQ from Mozhdeh, where we collaborate on some project. What do we do? So our main business, our main activity are data collection. Could it be image or any kind of collection? And we have the processing of the data, especially imagery. We have liquid and solid spraying with drones, kind of like a new business. So we're spending a lot of energy trying to build the model around that. And we have some dedicated application for some clients. Next slide. So a business model for farmers is kind of interesting. It goes from point A to point Z. So we start with the data collection. Could it be from an RGB camera or multispectral, as we saw earlier? We process the images to reconstruct the field using dedicated software. Then there is a recommendation part where, for example, you would look for stress. Could it be water stress, insect stress, anything? And then we have last part, which is really localized action. So at DesChamps, we are experts for the data collection, processing, and the action part. And because why? Because most of the time our clients already have the recommendation part. Next slide, please. So we're going to talk about that later, but in Canada, we cannot really do a drone spraying. So we have to do it abroad to work. So we did some experience in Sri Lanka and in Costa Rica. Sri Lanka, Nicolas was there for 3 months to work on a fertilizer around the above tea plantation, where the objective was to help and maybe enhance backpack spraying. And then we have the Costa Rica experience, where it was a 1-year operation with different pilots, and it was spraying pesticide above banana, sugarcane, and pineapple. And here, the objectives of the drone was to go where planes and helicopter cannot go. Next slide. So what are the pros and the cons of using a drone in agriculture compared to helicopter? So drones are a lot cheaper as a hardware, like compared to an helicopter. It's a lot easier to buy and to operate. That's a big plus. It's easy to implement. To start a drone operation, there's a lot of factors, but overall, it's a lot easier than like operating a plane industry. Drones are perfect for hard to reach area. Could it be under power line or next to village or road? This is a perfect tool where plane cannot go. And it's ideal also for example, when we talked about the backpack operation, when you have a lot of needs of manpower, low value job, drone is perfect to help with that. And also the most interesting part for us is the ecological part, where with a drone and the use of AI and technology, as we saw, we can spot the area where the stress exists and target it. Now, the not so good part. The first part is operating a drone. You need a lot of logistics because there are so many limitations. Could it be the battery life, or the size of the tank that are really small? If you want to be effective, you need a lot of planning and making sure the drone fly as much as possible. Then you have the issue with the low daily workload because a drone is not a plane, so you can just spray in a limited section of the field. And then we have everything related to regulation, because it's brand new, it's kind of complicated, so it's a lot of hurdle if you want to build a business around that. And finally, a point where we have to, let's say, evangelize is explain to the farmer why the drone is a good option for his business. Next slide, please. So regulation. So we have three main actors who handles regulation in Canada. Federal part with Transport Canada and Health Canada, and provincial part with the Ministry of Climate Change in Quebec. Next. So Transport Canada, you know, it will mostly talk about everything. Well, everybody who knows about the transportation and aerial knows Transportation Canada. So there is a lot of existing regulation about airspace, about where and how and when you can fly. And I mean, everything you need to know, you can find it quite easily. It's very well done. But now what's important for us are the future subject. What Transport Canada is doing right now. There are two main things. We have BVLOS, so flying a drone above visual line of sight. So for example, when you send a drone to deliver goods in north of Canada, a drone or a plane that will fly for like hundreds of kilometers, you cannot see it. So there needs to be an update on the regulation with that. The other part is autonomous drones. Drones where don't need a human to prepare and set up the flight. Basically a drone where you prepare the flight once, and then the day after that, you can fly alone. And it's going to be a great advantage because if you can operate a drone from hundreds of kilometers, it's going to be a lot more efficient. And the last subject of attention is drone swarm, where one operator can, for example, use 10 drones at the same time. It's going to be a very good help when you have a very large field to take care of. Next. So after Transport Canada, we have Health Canada. So Health Canada, with its PMRA arm, ARLA, his role is to authorize the product in relation with the manufacturer. So what's important for us in drone is that since 2019, so quite recently, there is a notice from Santé Canada requesting that the product be reapproved for drone application, chemical product. So at this time, there is no product that is approved to be used with drones. Every project we have is mostly like R&D, and it has to be reapproved. Everything has to go through the manufacturer. So this is a big hurdle at this time to use drone for spraying in Canada, and that's why we are doing it abroad at this time. Next. And then finally, we have at the provincial level, the MELCC. So its role is more to take care of everything, the application method, and to handle permit and certification and product management. And very recently, the latest news is since this year, it appears that no drone is considered the same as aerial spraying, just like a plane or a helicopter. So it means in terms of regulation, you need like the C1 and CD1 permit to operate, which we have. Next. So yes, we said that in Canada, because of regulation, it's kind of hard to build a business model around drone spraying, which is kind of bad because the public and the farmer are eager for new methods to spray less in a better condition. When you can analyze your field, spot the area where you need to spray, and use a drone to spray, it's so cost effective and very ecological. But Canada is very regulation oriented. Our experience shows that in other countries, as we said about Sri Lanka, Costa Rica, or any other developing country, there is a lot less regulation, and the use of new technology is more accessible. Nicolas will talk a little bit about that. And what we can say, for example, we have a partner in Switzerland, and very recently, drone spraying has been in the law considered like a traditional tractor spraying. So, you know, they took a different approach from Canada. So it's always a lot of pros and cons to use a drone, because it's brand new and it will need a lot of time to reach its maturity and have a rule leverage on it. That was all for us. So thank you very much. We are Drone DesChamps, and on the next slide you can see our contact and visit our website. Thank you.
Merci beaucoup, Gilles. C'est apprécié. Thank you. Thank you to all our speakers. I think we got a lot of great information. You know, the agricultural industry is one of the oldest industries, I think, in the world. And you know, if you talk about the history of it in Canada, and Ken went through that, you know, helicopter operation in that industry is still fairly recent, but now it's evolving. As you can see, there's a lot of, you know, as Mozhdeh mentioned, sensors being introduced in those operations. And Wesley talked about you know, how we traditionally have been designing spray systems, but not only are the systems that we use to apply the agricultural spraying system kind of evolving, but also the actual vehicles are evolving as well in terms of, you know, using UAVs instead of helicopters. So we're living in kind of a world where all of the, you know, the application, the way we're doing it, the vehicles we're using are all evolving together, and it's kind of very interesting. And we've got a great set of panelists here, a very broad set of expertise. So if there's any questions, I'd open up the floor to the audience. Please ask anything right now if you want. Either through, you know, messaging through the chat, you can send me a private message, or you can, or to the public, or even, you know, unmute yourselves and feel free to ask anything.
So Tuva, the currently attendees are not able to unmute themselves. If you like, I can open the mic, though just as a warning that could devolve into quite a bit of noise. So it is up to you, and we could remute as we need to if we ended up muting everyone.
Yeah, if you could unmute everyone, Chris, just give it a try. Let's see.
Sure. Okay, attendees, you should be able to unmute yourselves. All I ask is that you are patient with other speakers.
Wesley, I'm curious, what are the pumps on the agricultural helicopters? I had that one picture of the Robinson where it had looks like a gas-powered pump, but how are the spray systems generally powered?
That's a great question, Ken. So it all depends on the available power of the aircraft. Usually our default is to go with electrical power if the aircraft has the juice to be able to power an electrical pump. In the case of our Robinson 44 pump, the Robinson 44 just did not have a robust enough electrical system to be able to power that pump. So we bolted on just an essentially an off-the-shelf Honda pump or gas motor that does that. So, you know, there's pros and cons to that. There are some customers who will say they prefer having the gas-powered pump because it never, you know, it's got lots of power, it can do the job. But you know, it's an added thing you have to, that the operator has to manage. You've got Jet A1 fuel for your helicopter you got to manage. You've got your liquid that's going into the tank to manage. If you now have to manage just general diesel or regular gasoline to go into that pump, it's another fluid to manage. So that's why the DART, and before, you know, the acquisition, Simplex's preference was to go with electrical power.
Thanks. I'll keep asking questions, but the
I
audience.
see a few people unmuted. I don't know if there are questions in the audience. Pat or Martin or.
Yeah, that's worth mentioning. Edith has put into the chat that the YouTube videos that DesChamps has put out there are absolutely spectacular. You know, some very scenic footage coming, particularly of out of Sri Lanka. There's some really good stuff worth watching there.
Yes, thank you. We are using mostly a DJI drones from Enterprise division. Why? Because they were the first to offer this kind of product, and they're kind of reliable. I mean, like hardware speaking, it's working well. The software, it's another question. But there is a lot of improvement. DJI has been offering new drones with a bigger tank capacity, longer battery life. But definitely, it's still a big challenge. The technical limitation of drones compared to helicopters or airplane, it's something to work on. That's why actually drones are complementary to helicopter. They will not, in the short term, replace them, because with an helicopter you have such you know, like such hardware to process very large area. So we're not we're like your best friend that do the work that you cannot do.
Good way to put it.
Yeah, I don't know. We'll see. I think a couple of the technical hurdles that you outlaid in your presentation, if those get cleared, I think you could make a pretty compelling argument for one pilot flying half a dozen drones covering as much ground as a helicopter. We'll have to see which direction the future holds. There's some regulatory changes and some technical hurdles to clear, but I could definitely see, you know, this industry looking extremely different 10 or 15 years from now.
I have a question for Mozhdeh. The things that you described and showed in your presentation, are there farmers today in Canada that are using this technology, or is this something in the future? And like, where would we see this applied or in taking place today? Because I have no idea.
Well, yeah, some of them, it's actually a project that data was collected also by DesChamps, and the farmer is interested in the results because the results will help them identify the problems that I pointed out. So the other project where we've been simply doing 3D mapping using LiDAR and then vegetation removal to give them the microtopography of the soil, because their farm is actually eroding because it has a very steep slope towards the river, and it's kind of eroding. So they are interested in knowing the microtopography for that. So I think some farmers trust this type of technology, some don't. But I think it depends really. Or the project with the potato field, it's also at the request of the farmer. The cameras are installed on the truck, on the sprayer, actually, the sprayer machine, and so it's also type of monitoring they're interested in. So I think it really depends on the farm management whether they are interested in using this type of technology or not.
Yeah, if I may complete, that's a very good question you're asking, Ken, because if you come to a farmer and say like, oh, I'm doing artificial intelligence, I can give you like a density map, it's like, okay, but how will I use it? And the biggest challenge we have right now is how to connect the, let's say, software or technological part with the supply chain. How will it help them? Will it help them to better understand how much they can sell to Metro or IGA? Will it help them to better understand how much they need to buy from other companies to fulfill their order to IGA? And the biggest issue is that, you know, farmers, they have their own method, they have their own instinct. So some of them have been doing that for 30 years. So they kind of know inside how to calculate a yield, for example. But when you bring them numbers in an Excel chart or how do you add those numbers to their methodology? Because even them, they don't know how to calculate the yield. They look at the field, they know the historical growth stuff, but it's very, very hard. So I would say that the biggest farms are the more interested in technology because they are businessmen. They have to improve their profit and reduce the loss. So if you offer them like a robot or like a spacecraft who will do the work, they don't care, because if they understand that technology will help them financially, and those people, they have the resource to spend money for 3 years, 5 years to test something. So everything takes a lot of time, you know. Probably, I guess when first farmer you saw helicopter, you know, they were like, I don't need that. I can do it, you know, working the field. And maybe 20 or 30 years after, they see the full potential. And right now, with everything imagery and drone and automation, we have the same issue.
We do have one question in the chat, maybe for Drone DesChamps. Timothy is asking what the typical payload level is for UAVs that are carrying this equipment that you're using, the spray equipment, the weight of the spray material and all of that.
Yeah, so our drone that we have, it's a 10-liter tank. So this is like the average. The new commercial drone, you can see probably like 15 or up to 20 or 30 liters tank. But the issue that we have is you can have a big tank, but the drone can only fly for like 30 minutes. So if you have a 100-liter tank, but you have to go back to the ground every 20 minutes to change the battery, it's no use. So when I say that we have a lot of operation planning, it's making sure that the drone stays on the ground the less time possible. And what we're looking into is there is some company in Canada, Quebec, they have like, it's like a half-size helicopter, remotely operated. It could be used for like an inspection or surveillance, but also have probably like 100-liter tanks. But those machines, you know, they're like a helicopter. They fly with gas and not electricity. So this is a big limitation, the relatively small size, 10 to 30 liters per tank.
And it's interesting for the regulation because we are under 25 kilos and it's not necessary to have a SFOC. SFOC, it's an accord, an agreement with Transport Canada is necessary. And
yeah, because up to 25 kilos, it's very easy to have the right to fly. Above 25 kilos, you need some paperwork. So for us, we would rather, in operation, we would rather have a small tank, but a lot of battery. So we can just like refill, fly, spray, and go back to the home base and change battery at the same time. So it's a lot of consideration to have, because flying an agricultural drone can be not efficient if you don't know what to do. That's
Yeah, it's very interesting that you have both regulatory bodies from Transport Canada and Health Canada involved in your rules. I didn't think that they would both be, but I guess because you have, like you said, aerial vehicles that are administering medical type products or like chemicals, essentially. The UAV would be proof for that purpose. So,
yeah, definitely. But the more government body you include, the most complicated it becomes. Thank God, Transport Canada, you know, they make everything for the drone sector to grow. As a business, so it's very good. Santé Canada, they're handling everything else. So to have things change, it's a lot more complicated, especially when you need the manufacturer of the product to be part of the approval process, because manufacturer, they have that business model and they don't really like disruption unless they can make some good profit. And so it's a challenge. But I mean, like government and the public, especially in terms of ecological point of view, is very receptive. So overall, in the end, I think it will work.
A couple of other questions from the chat. Someone's asking.
Just to finish,
Yeah, sorry.
we have. Alors, je vais parler en français parce que je sais pas trop. Peut-être que quelqu'un me traduira. Par rapport aux hélicoptères et aux avions, aujourd'hui, il y a une régulation en matière de développement de produits pour faire de l'épandage, développement des sprayeurs, etc. Et aujourd'hui, il n'y a aucune régulation sur les drones par rapport au système d'épandage. Donc, on passera dans une deuxième phase, là, qui sera aussi très importante, c'est qui est-ce qui va réguler les équipements d'épandage pour les drones? Ou comment cette partie de la réglementation va être mise en place? Et là, il n'y a aucune information sur ce point-là, en fait. Et que ce soit au Canada ou dans d'autres pays.
Yeah, it's a very valid point for those unilingual folks in the audience. What he was saying was that the regulations around certifying the equipment that gets used on drones for aerial applications isn't clear yet. And so, I mean, as someone who works for the company that does that sort of that sort of job all the time, there's a cookbook called MG5 that's released by the FAA that gives you all the requirements for how to certify a belly-mounted equipment for agricultural applications in the rotorcraft industry. So that's our Bible, really, for us whenever we're going out to approve any belly-mounted tank, whether it's for firefighting or agricultural applications or anything else. Those regulations aren't mature yet in the UAV space. So we're waiting with bated breath for the regulators to show us, of that big book that is Part 27 and Part 29 approvals for how to make airworthy helicopters, how many of those apply when there's no passengers or pilots on board to keep safe?
Just a couple other questions. I know we're a little bit over time, but maybe we can try to hit up some of these. Martin Landry was asking, have drones started to be used for 3D mapping construction zones to minimize work, reduce for new roads? I think, yeah, personally, I've seen that actually a little bit, but maybe Nicolas or Gilles, you know a little bit more about that, or even Mozhdeh.
Oh, yeah, so drone for 3D reconstruction, definitely. You can use a camera or like a LiDAR for the point cloud, and it will be very effective to scan and recreate the site on your computer. Now the next step is VTOL, so small airplane, remotely controlled airplane. If you want to do a very, very large surface, right now the only option is either satellite or like a plane with like a very, very large sensor. But with a VTOL or drone and the always increasing resolution of the camera and new technology, 3D reconstruction for construction site, for infrastructure, definitely it's very effective. We have a lot of work in that area. And I know like Mozhdeh shows some of the other sensors, like 8 camera sensors that can like reconstruct using point cloud and RGB camera at the same time.
Very good. And Mozhdeh, a question for you. How does this technology compare to satellite services available? Is it complementary, and could the data be acquired from the ground from a tractor, for example? Was the question.
The end of your question, what was that?
Yeah, so I'm gonna repeat. So how does technology compare to satellite services available? Is it complementary, and could the data be acquired from the ground from a tractor, for example?
Yeah, exactly. So one of the projects I showed, the data is actually being captured from the sprayer tractor. Then I think in terms of comparison with the satellite data, well, viewpoint of the satellite data is very specific. It's bird view or nadir point of view, depending on what kind of satellite. The time they pass over your farm is also very particular. The resolutions are limited. Well, maybe with satellites like planets or SkySat, you can get meter level resolution, but if you need like leaf level or plant level analysis of your farm, then you have to get closer to the plants. So whether by installing sensors on farming machinery or just using drones or low altitude flying helicopters with higher resolution sensors. So one of the photos in one of the slides I showed was actually sensors on the R44 helicopter, but these sensors have higher resolution, so the result will be comparative to what you can get with the low cost, low resolution camera on a drone, for example. So it really depends what kind of information you want to extract, at what the scale and at what resolution, and also at what spectral bands or what kind of spectral information you also need.
Thank you. And one more question, I guess for the group. Actually, this one is for drone DesChamps. Might have been already answered. How many liters can the drone carry? And what type of spray system does it use?
So how many LiDAR can you place on the drone?
How many liters can you place on the drone? Yeah, liters.
Liters, okay. Well, in terms of product, liters between our drone, mostly 10 liters. A new version of DJI can do like 15, 20, and 30 liters. But after that, as Nicolas said, if the drone is too heavy, it goes above the regulation for like Transport Canada, and then you have to apply for more certification to do the operation. And the second question, sorry?
What type of spray system does it use?
Nicolas, c'est quoi les sprayeurs sur le drone?
It's normally it's like T-jet sprayer, like a traditional spraying system on tractor.
Okay. Very good.
Some drones are equipped with specific sprayer, but so no, normally it's T-jet sprayer, and you can spraying drone is agronomically is like a tractor but with land.
And yeah, so what's good actually is there is a lot of let's say R&D projects from companies that try to build custom sprayer. And Earth sprayer, if you look at the DJI Agras, you know that like 4 sprayer just below the rotor. But more and more you're going to see like systems that looks like what we saw for the helicopters. So a wide sprayer system. It works. We've seen some of those projects. So there is a lot of new technology, new things to build and to use.
And just to complement what Gilles was saying earlier about drones and helicopters, how at the moment the work that they're doing is very different. The systems that we make for the Robinson 44, it's a 284 liter system. For the Robinson 66, it's almost 500 liters. And then the largest system we have in production for the Bell Medium is 1400 liters. Now that's a very different application and a completely different cost structure compared to what someone would do if they're using, say, a Jet Ranger or an A-Star or a Robinson.
Yeah, that's why, because where we have been the most successful, or like where our clients have been really requesting drones, is where the plane cannot come, or the helicopter cannot come, when it's too close to cities, to road, to the canopy line, where it's too dangerous or too costly for an helicopter. A drone is perfect, because even if it's a model are kind of expensive, but if you compare the cost to an helicopter, which is like very expensive, a drone is a piece of metal. If you break some part, you can always replace it quite easily. So it's it's a different business model.
Gilles, just one quick question. What's the typical day? You've been operating drones overseas in Sri Lanka and Latin America. What's the typical day for a drone company when you're working? Do you only work part of the day, or how does it work? What happens?
Nicolas, raconte-nous la journée type d'un pilote de drone au Sri Lanka.
Alors, la journée type déjà d'un pilote de drone au Canada, c'est très saisonnier, hein, comme vous le savez. Donc, on bosse énormément en opération la saison d'été. Et elles sont, j'ai l'impression, de plus en plus tardives. Donc, elles commencent là au mois de juin et elles vont terminer au mois de septembre-octobre. Et sinon, au niveau des opérations, la journée type au Sri Lanka, par exemple, c'était se lever, aller au chantier. Souvent, on est accompagné de beaucoup de monde pour tout ce qui était chargement de batterie. Et ensuite, c'était que du vol à vue. Donc, comme un pilote d'hélicoptère, là, il n'y avait pas de programme de vol parce que le Sri Lanka, c'est des moyennes montagnes. Les plantations de thé, ce sont des moyennes montagnes avec des arbres un peu partout. Et donc, le jeu, c'était plus de slalomer autour des arbres pour réaliser l'épandage et de s'assurer que le drone ne crache pas, que de juste lancer un système de pilotage automatique qui réalise un plan de mission très commun, on va dire. Donc, les opérations, ce type d'opérations d'épandage sont quand même très demandantes au niveau cérébral parce qu'on ne peut pas se permettre de perdre le drone à vue, en fait. Pour des raisons, les raisons environnementales qui font que c'est tellement complexe qu'on doit garder l'appareil en l'air et on ne doit surtout pas avoir de problème. Donc, on fait très attention à tout ça. Ouais.
Just to translate again for both, or Gilles, you can do it as well. But basically,
no, yeah, you can go, Thomas.
Well, I mean, from what Nicolas just said, I mean, it's very seasonal in Canada, right? So it's mainly summer operations around the June time because, of course, with the weather, it's hard to fly. And then when you're in Sri Lanka, of course, you know, basically you get up early in the morning, you go out to the field, and you know, you have a bunch of people for mainly changing batteries and things. But of course, I can understand you're operating in mountainous regions and there's a lot of trees around, so you know, there's no typical flight path. You do have to avoid those trees when you're flying, and you don't want to hit one and cause you know, not just damage to the drone, but potential environmental impact in terms of the spillage that could happen. Did I cover that well, Gilles? Or if,
yeah, but yeah, definitely. It's a long day in Sri Lanka because when we are in operation, we start very early because this is the best time to fly. The biggest challenge is probably you spend more time on the ground than flying the drones overall. That's where we're trying our best to be super efficient and have the drone fly as much as possible. There are two things that Nicolas said that when we flying the drone, you can do it automatically. So you prepare the flight plan on the computer and you push a button and the drone goes by itself. So it works on certain conditions. When you are above an open field where it's the same level, it works very well. But for Sri Lanka or some other operation, we cannot do that because the terrain is too dangerous. Then we have to fly manually, just like an helicopter, without a prepared flight plan. And it's very stressful because you have to keep an eye on the drone all the time, making sure you can avoid obstacles, even if we have obstacle avoidance hardware, but sometimes it's not working, the altitude, etc. So yeah, but definitely the logistic around using a drone for agriculture, it's more work than flying the drone actually. It's because if you you with a plane you come do one pass, it's done, I guess, but drone it's a hard thing.
So we're a bit over time here. Some great questions. That kind of concludes the questions in the chat box, at least. I'll maybe do one last call if there's anybody who wants to shout out a question. No, I guess not. Well, I mean, thank you very much to our speakers. It was very interesting. Thank you all for coming out today. And thank you to the audience as well for coming out to listen. And we look forward to future events. Thank you, everyone. And Chris, I guess we can end the session there.
Thank you. Thank you, VFS. Thank you, everybody. And have a good night.
Thank you.
Have a good night. Bye.
Bye.